Hey everyone, and welcome to Follow the White Rabbit, where we go down the rabbit hole to explore the intersection of privacy, human rights, technology, and democracy. I'm your host, Alex Kahaya. Today we are speaking with Kurt Rohloff, who is an associate professor of computer science at the New Jersey Institute of Technology. He's the recipient of a DARPA Young Faculty Award and the co-founder and CTO of Duality Technologies, a startup focused on privacy-preserving data science. Duality Technologies develops and integrates encrypted computing technologies to enable privacy-preserving analytics in regulated industries such as healthcare, finance, and government. Thanks for being on the show, Kurt.
Great, happy to be here. Looking forward to talking.
Yeah, I'm really excited to talk to you. I think one thing I could have added to that intro is you're a pioneer in open source, which we have some luminaries on our team. Brian Fox, who's a pioneer in the open source space too. And then obviously your work in homomorphic encryption is super important and something that I think I come from the blockchain space. There's a lot of people working on privacy related technologies and encryption and things like zero knowledge proof. So excited to have you here today. Maybe we could just kick things off with just a little more about you and your background and where you're coming from so that people could get to know you a little bit better.
Yeah, sure thing. So I'm an engineer by training, bachelor's, master's, PhD, whole nine yards and everything else. I was of the generation that happened to be in engineering grad school during the 9/11 attacks. And so early on, I graduated soon after with my PhD. I got basically, very interested and basically moved into the U.S. defense industry and particularly worked for one of these very pioneering companies called BBN Technologies. I consider it probably one of the most important companies no one's ever heard of. I had an office down the hallway from the man who invented email, for example. And it was the company where they did the first ARPANET routers. It became the eventual internet. And so BBN had this legacy of doing work for DARPA, national defense, national security. And I was very happy to kind of, do my small part of helping to develop technologies as part of DARPA mission. And, I happened to be at the right place at the right time when in 2009, there was this theoretical discovery of this concept of homomorphic encryption in an actual workable protocol. It was discovered by this gentleman, Craig Gentry, who was then a Stanford PhD student on intern at IBM. Concept behind it is that one could take encrypt data, encrypt it, encrypt the data in a way so that no one can get access to it, and then run computations on the data while it's still encrypted. And it was seen as kind of like this vision of how one could basically, secure clouds, be a panacea for everyone's problems, and unicorn kisses and mother hugs and things like that. But the real world was that it was slow, it was hard, and DARPA got very interested, and I happened to be in the right place at the right time to basically run the team, the first implementation team, funded by DARPA to basically make this work in a real way. And frankly, I just drank the Kool-Aid on it. There was some internal motivation of this related to privacy as a human right and things like that, kind of behind the scenes for freedom of speech and things like that. But just the way life is, sometimes you bump into these just amazing projects and it changes your life, which is what happened to me with this kind of opportunity I was given at DARPA to, do a lot of the early work on homomorphic encryption. And so, I can kind of go into the story from there, but that's really how I personally got into privacy was by this really exciting new breakthrough called homomorphic encryption back in 2009. Yeah, no, good question. So the early work I was doing for DARPA was really just super basic research. Take a pile of equations written in LaTeX and try to get it working in software and hardware so that you can actually do something. And something's better than nothing. And the very, very first implementation of this scheme that was done by IBM to basically motivate a lot of the early DARPA work was encrypting 2 bits and then running a bitwise AND on the encrypted bits, and then bootstrapping, decrypting them, and that operation took a half hour just for a single bitwise AND operation. And so the reality of where homomorphic crypto was miles and miles and miles away from anything that was even remotely practical. And so over the course of the DARPA project, we got to the point towards the end of the project after 4 years, and this was around 2012, 2013, where we got it fast enough so we'd actually deploy homomorphic crypto on what was then the stock, latest and greatest iPhone, actually iPhone 5S. Run encrypted VoIP operations, like actually encrypt people's voice on the iPhone, send it up to the Amazon cloud and commercial data networks, and then have basically multi-party VoIP and with end-to-end crypto for basically people to kind of talk without having to decrypt anywhere along the way. And so it was like, first ever kind of functionalities. And like I said, live VoIP streaming on encrypted data. It was like, from where it was 4 years ago to then, frankly, I just drank the Kool-Aid on it. And I thought it was the best thing ever. So, it really wasn't a good place at BBN to continue that work. So basically, I left. I took an academic position at NJIT, New Jersey Institute of Technology. I got recruited in for a number of reasons. But, DARPA kept on funding my work. And kind of like the next step was, we did the initial proof of concepts during the first program called DARPA Proceed. And over the second program, which is called DARPA Safeware, we co-founded this open source library called Palisade to try to take this kind of initial design work and put it into something that was repeatable, so it wasn't just a one-off kind of thing that we can keep on reusing. And basically, it took off. I mean, there were other players in the defense industry that started using it and building off of it. And it got to the point where two of my early collaborators at MIT, Vinod Vaikuntanathan and Shafi Goldwasser, we decided that we wanted to co-found a company called Duality. We very quickly learned, I know we were chatting before the show about, proving out technologies and things like that. We quickly learned that there was a lot more to a tech business than just tech. And we then got connected with another, really strong co-founder, Ms. Rena Shansky, who came out of the VC community in Herzliya and Israel. And then Alon Kaufman, who was running global data science for RSA, and formed this company that was called Duality. And we use this Palisade open source library as kind of like a cornerstone of a lot of our products, but we happen to be very, very firm believers in open source and the need for open source crypto for trust and for transparency. And other people use our library. I've been told some of our competitors actually use our library. What we're just happy about, because it just means we have something that's real and something that's useful. So.
Couldn't agree more and love that sentiment. And I think that, anybody who comes from the crypto space, whether that's from a cryptography lens or a cryptocurrency lens, blockchain, that's been the lifeblood of our industries is open source. It's the right way to do things. So that's really cool that you guys took that on. So you formed Duality, and can you tell us, before we started the show, I was wondering how, what your exposure was to things like zero knowledge proofs, which is a really important feature for blockchain technology. It's something that we had a guy on the show that we just released his episode, Alex Glukowski, who runs a company called Matter Labs, and they just released a thing called ZK Sync, which is a way to do scalable zero knowledge proofs on Ethereum. So they're trying to make the transactions more private and also provide smart contracting smart contracts that are also private using zero knowledge proofs. It's kind of one of the holy grails of the space, so that you're not like, you could still leverage a public ledger, but but still maintain the privacy around your transactions. So you have some people on your team that have knowledge of that area. You could talk about them a little bit more and tell us that background too.
Yeah, sure, gladly. So I kind of glossed over a little bit of who the co-founders are, and even who the co-founders of Palisade are also. So the early academic co-founders, science co-founders, one of them is Shafi Goldwasser, happens to be Professor Shafi Goldwasser of MIT in Berkeley, also happens to be a Turing Award winner, which is kind of like the Nobel Prize of computer science. She's the inventor of zero knowledge proofs, which is basically her claim to fame. We happen to have co-founded Duality back a few years ago when it seems like blockchain was kind of like the thing for Silicon Valley and the VC community. And so it was a little bit kind of funny at some level that we were going to VCs with the inventor of zero knowledge proofs and not doing something blockchain.
Yeah.
So, but I think it kind of speaks to how we really thought that, homomorphic crypto was really where it was at and what we really believed in. My other science co-founder is uh, Vinod Vakanathan, Professor Vinod Vakanathan, who happens to be an MIT professor in his own right, won the MIT Best PhD in CS award, once upon a time, and was also a DARPA Young Faculty awardee several years ago also. So we have a pretty strong science team that kind of pushes forward on that. And there's been a number of back and forth kind of connections that we've had with the blockchain community. As we were chatting before, there's a pretty tight community of people that do applied crypto and implement
Yeah.
crypto, and we all kind of know each other, or at least connected at some level. Um, when homomorphic crypto is a very new technology, a lot of people haven't been exposed to it. A lot of people haven't even heard of it. And I could, if I had a nickel for, every time I heard a VC call us homophobic encryption, I probably would be able to self-invest as much as anything. But we had to just explain what the term meant at first to start. But as we were kind of going through, um, we got a very strong message from the market that to build up trust in the technology, it would help a heck of a lot if we could show that there was a notion of a standard and show that people were using it and show that there's real market around it. The homomorphic community being as tight as it is, we basically knew who all the other major players were, and we happen to be particularly close to the teams that were at IBM, which included Craig Gentry, who was, as I said, the inventor of homomorphic crypto, Shai Halevi, who was one of the early other performers on the DARPA program and pushed forward one of the early libraries called HElib. And then at Microsoft, there was another team run by Kristen Lauder and Kim Lina, who had the other major library called Microsoft Seal. And the three of us basically decided that we were stronger together than they were trying to compete. And we co-founded a standards community called homomorphicencryption.org to basically design standards to standardize both the protocols and the security settings of homomorphic crypto, to also as an industry consortium to send a signal to folks like ISO and ITU, the major standards bodies, and NIST also, that there was broad commercial interest in this. The community had ended up taking off, and we've had participation from SAP, from Samsung, from Intel, from Visa, US Navy shows up, NIH shows up, and Korean Credit Bureau shows up and things like this. And so we got interest from the blockchain community, and they co-formed this blockchain standards community also, at kind of at the same time under a very similar model of us, basically industry consortium to go and build trust. And as we know, privacy and crypto and cybersecurity really is all about trust. And the more that we show community cohesiveness, well, a rising tide floats all boats in these kinds of ways also. So community is just tremendously important for us in the community.
That's incredible work, and I think totally on point. So, I'm curious to learn more about some of the impacts that your technology is having. I think I'm always interested from a business perspective, just because I'm an entrepreneur and that's kind of what I gravitate towards. But there's certainly some things that are probably not market necessarily opportunities for this technology, but still have a good impact on the world. So, I would love to hear about both. How are you guys using this as a company, and then what are some of the other impacts that it could have?
Yeah, sure thing. And like I said, I came out of the DoD DARPA domain, and so I'm familiar. It's almost like two parallel markets where they kind of what counts for taste in the commercial side, doesn't really mean much for the military, but the military might love something, and the commercial world would be just like, I don't care. And so it's kind of interesting to see how the homomorphic crypto technology has kind of moved in parallel on both sides of that. Commercially, we see this as a really strong tool for collaboration on data. And so we have a product that we call Secure Plus Query. And the notion of Secure Plus Query is two banks want to collaborate. And what the banks have traditionally have had a lot of trouble with financial crime, a lot of trouble with fraud, a lot of issues with money laundering. And the major banks, we could do a Google search and find them in about 5 seconds, will get multi-billion-dollar fines from US government and other governments for not being aggressive enough about fighting money laundering and things like that. And so the banks to have this notion of They have a pile of data that they're sitting on about their customer transactions. Other banks have other piles of data that they're sitting on their customer transactions. It benefits both of them to collaborate if they can to fight money laundering, to basically remove the risk of these fines. But at the same time, they don't want to share the data because they don't want to give away their customer information, both for privacy concerns and also for competitive issues. They don't want to give a leg up to their competitors. And so we have this product that basically allows Bank A to take a query that they want to run on a specific account. It might be like, give me all the information about the accounts you have. How many accounts do you have at this address? 1600 Pennsylvania Avenue, for example. And take that query, encrypt it, send it off to the other bank. The other bank can take that encrypted query, can't see what's being asked about, but run it through their data and generate, for example, account or other kinds of information about how many other accounts are actually they have at that same address. Send it back over. The other bank can then decrypt. None of them share any sensitive information or anything else, but the bank that's running the investigation can then say, hey, is there one account to this address or is there 50? One account, no big deal. 50 accounts, well, that's kind of suspicious, and you better start looking into it a bit more. And so that's one of the places that we're playing on the commercial side to allow, for example, financial services to collaborate, fight crime, fight human trafficking, and things like that, and basically reduce loss and improve profit, as they say. On the less commercial side, and more the kind of the DoD side, very similar kinds of issues that we're bumping into, but more associated with information access control. And so this is like a classic example is, it might be various kinds of allied forces might be operating in a region, and they might have different information that they want to share with other allied forces. Hypothetically, let's say like U.S. and Canada, for example. They want to collaborate, but they also want to be very sensitive about sending information to folks who really they don't want to really know a lot of stuff, but they want to know a little. And so it's a way of them, for example, encrypting intelligence reports, sharing it, sharing that information in an encrypted way, delegating access in kind of some sort of like publish subscribe type format, but being able to encrypt information about who gets access to what the access rights are, and provide more of a finer grained cryptographically secure access control mechanism. And this has not been something that we've seen, that we're not focusing on as a commercial product of Duality, but it's been driving a lot of our uptake of use of open source Palisade in different parts of, for example, the DoD, for example. So.
Very cool. Yeah, and I imagine there's a lot of use cases in healthcare as well on the commercial side. I mean, just with I've been involved with some tech-enabled research clinical trials in the past year with groups working on some open source projects in that area, and definitely this kind of technology sounds really useful for that. When you have large amounts of patient data that needs to be analyzed in a HIPAA compliant way, and how do you do that? And how can you share? Here's the question: how could you create open data platforms that allow you to analyze data? You can't. That needs to be HIPAA compliant.
Right.
And I saw something that you sent me about that with COVID-19 research. Maybe you can speak to that a little bit, or some of the applications you guys have explored in that area.
Yeah, gladly. So we were originally exploring several areas related to how we could enable a certain kind of computation on genetic data. So as you're probably aware, there's been a bit of an explosion in the past couple of years of various genome sequencing technologies, either for medical clinical applications or what's called recreational, like 23andMe and Ancestry.com and things like that. And so there's been all these creation of different data lakes, data centers that have data on specific populations and specific geographies, or specific ethnicities and things like that, depending on which country they're in and things like that. And often this data is very, very hard to move across different geographies. For example, it's very hard for a data center in, say, Iceland to share data with cancer research center in the U.S. And so we got some funding from NIH in partnership with a collaborator at the Dana-Farber Cancer Institute to look at how we could develop homomorphic encryption solutions to allow cancer research centers to encrypt their repositories of genetic data, share it in encrypted form, and then run these genome-wide association studies to identify correlations between various kinds of mutations and various kinds of incidents of genetic diseases, such as cancers. And so this was some work that we did, and it was actually collaboration with a gentleman by the name of Alexander Sasha Gusev at Dana-Farber. And we had a number of papers that we put out at the proceedings in the National Academy. We also, for example, got funding from this, so this is where it ties in with COVID-19, where to enable the ability to different data centers, different genomic data centers, to encrypt the data and see if there's a genetic cause and effect or a genetic correlation between various kinds of mutations and the incidence of severe COVID-19 infection. And if there are certain kinds of genetic markers that are indicative of, hey, you have this small mutation. Normally, it doesn't actually matter, but if you get COVID-19, you're going to have a bad time of it. Take extra care, and that's the kind of technology that they're trying to enable. It really is, in some sense, a generic kind of capability of looking at correlations over large data sets in an encrypted format. But we just happen to have, the application that's highly motivating, high value right now, as we all know, is the COVID-19 severity modeling, which we're moving on.
Wow, that's really incredible. That's really cool. So, what are you most excited about as far as what the future is for the technology and for your company? What's the thing that you're really, really getting pumped for the future?
Well, this is like I said before, there's more to a tech business than just tech. There's the business and the tech. The business seems to be, really moving quite well right now. We had a Series A investment led by Intel a few months ago. We're pretty excited by. I think it's as much a validation of what we're doing as anything, but the real validation is in market and customers and everything else. And we seem to be having an accelerating uptake of these technologies in relatively conservative industries, such as healthcare, such as finance, and things like that. And it's like kind of like the usual model of market adoption. We've had a number of really nice early adopters. We've had a lot of early uptake of this technology by market leaders, and we're starting to basically move into the mainstream as we go, which has been super exciting. And like I said, it's more about the notion of how one trusts this new technology is driven by open source, open standards, community adoption, and building momentum from there, which we see as very important for us and for our business. Of course, like I said, the other side, and I'm a technologist by inclination, is that we see the notion of training on encrypted data as something that is increasingly of value to our customers. Deeper analytics, much more complicated integrations, and in some sense, I like to somewhat tongue-in-cheek say, my main mission in life is actually to make homomorphic encryption boring as possible. So the notion is it doesn't take a room full of PhDs to kind of make this stuff usable and practical, so that you could just deploy it on a software package in Python or Java, or a middleware technology like anyone JNI or something like this through JNI, and go forward from there to basically make it completely transparent to the user, and so people aren't even aware that it exists. Similar to other kinds of networking technologies, is something remote or is it in the cloud? Is it encrypted or is it in the clear? At some level, people don't care as long as they just know that their information is safe, and be able to provide that in the most boring way possible is kind of our mission.
Yeah, I mean, two things pop up there for me is it sounds like once you get to that point with the technology, then you can really start thinking about some of these consumer applications where it's just behind the scenes and people don't really have to know what's going on. It's super easy to use. I'm curious. So that's the first thing is I'm curious what consumer applications you're seeing or envision in the future once we get to that point.
Right.
The other thing I want to touch on after that is, and just so I don't forget, is you mentioned training, and I think you were referring to machine learning data, AI, leveraging leveraging homomorphic encryption to train AI and machine learning. Would love to expand on that topic as well. But let's start with the consumer thing first.
Yeah, sure thing. So one of the early things that we looked at and was the notion of data as value. We have this notion of data being the new oil, right? It's like it has value inherently for what it is, and there's always interest in data monetization, whether it's large enterprise companies taking their data and leasing it to marketers, and we see it more as with homomorphic crypto as leasing data as opposed to selling data, for example. And same goes with consumers. Consumers have their genetic data, they have their health data, they have their financial transaction data. This has value inherently also. Even look at the example of drug trials. The notion of how one's health information, one's medical history, one's pharmaceutical history, and how they take various drugs and things like that. This is of vast interest to pharmaceutical companies for looking at what kind of correlations or causations might exist between the taking of certain drugs and potential clinical applications. And if someone could basically sell their data to a pharmaceutical company or lease their data to a pharmaceutical company, it allows basically individual consumers to basically get value in kind of their own sense, while individually selling their data on their own without actually being in some sense taken advantage of by having large enterprises sell or lease their data, like it is right now, as you saw for things like the Cambridge Analytica scandal and things like that.
Yeah, and that's a big trend definitely back in like 2017 especially. That was a really big trend in the blockchain space, is trying to create these kinds of marketplaces, right? Using blockchain technology as well as different kinds of encryption, which obviously is part of blockchain technology. But as far as like the data goes, creating these data markets, and I still think it's one of the most interesting use cases. Although I'm not sure that, do you really need like a decentralized blockchain in order to achieve that? I don't know. I'm not the expert on that, but it'll be interesting to see how this stuff gets applied. I think that there is going to be a market for that. I know that things like 23andMe sell your data without. I mean, I guess you kind of consent to it, but you probably didn't know when you were getting your genetic, giving them your genome that was what was going to happen. But is that kind of a marketplace, something that Duality is thinking of potentially building it, or do you think it's just something that like would be interesting to see happen, once the technology matures in an open source environment?
Well, this is one thing I've learned as an entrepreneur, right? Never say never, right?
Yeah.
We're not actively pursuing it right now. That doesn't mean we won't, but I think it's something that we did look at early on. We decided, like I said, to go focus on financial services and these other kinds of applications I mentioned in passing. But I do see it as something that is a potential use of privacy technology to basically give more power and more control to individual consumers of their individual data as they go.
And so let's go back to the training thing. So are you guys actively using your technology to train AI and machine learning? Do you see what are some use cases you see out there for that that would be interesting to share with people?
Yeah, sure thing. So we recently had a project that we announced a few months ago that was a collaboration with University of Michigan. They have the Institute for Data Science. Actually, I'm blanking on the name, but they have an Institute for Social Research at the University of Michigan that's funded by the Sloan Foundation, and major benefactor of science education in the U.S., in addition to other kinds of beneficial activities that they help support. And part of the mission of the Sloan Foundation, in partnership between us and University of Michigan, was to develop a way where the researchers at Michigan can collect data on education and grant making across the major universities in the U.S. to see the impacts that different kinds of grants and different kinds of financial interventions have on the long-term financial health of students. So, for example, seeing if students, for example, raise their socioeconomic status and kind of go on and become major generators of patents and major generators of innovation and co-founding companies and things like that, and it's basically the goal is to basically use this data to help economic researchers look at the effects of grant making. The challenge with this is that education data, financial data, it's super sensitive. And so the way Michigan has been operating, this Institute for Social Research has been operating before, is that they would set up basically a secure enclave of data. And you would have to go and sign these very aggressive data use agreements, be subject to all kinds of liability issues and things like that. If you leak the data, you can log into the system and it's very locked down and only so number of people can get it. And the vision is how can we enable social science researchers to get access to the data more easily so they don't have to take on all these liability issues, to basically make data more freely available, protect the privacy of the students, protect the privacy of the grant makers, but still enable and accelerate the pace of economic research to see how different financial interventions help students. This is just a fundamentally good thing for society in general. And so we've been developing a set of general techniques as part of this project to enable researchers to go and specify different models that they want to train. For example, different logistic regression models, different kind of linear regression models, so that they can train on this data, take it and generate a model on encrypted data that they can't leak by just inherently by the nature of the crypto, but at the same time do better research, do faster research, more effective models than they would normally be able to, and then get better insights that they could share with, for example, policymakers or other academics, and going on forward from there. And this is one of the early examples that we have of how we're trying to enable training on encrypted data to allow people to get access to data they wouldn't normally be able to get access to, and then just build machine learning models that are just basically more effective than had been possible at any time in the past.
It seems like the tooling that you would have to build to make that project a success is probably reusable across a lot of different data sets.
Yeah.
Am I? Yeah.
No, it's a good point. This is kind of the other tongue-in-cheek thing I like to say is, the best engineers are the laziest possible, right? Reuse as much as possible. This whole nature of open source at some level. You solve a problem once and solve the problem for the rest of society. At least that's the vision. It doesn't always hold the case, but this is the nature of being a good software engineer. Also, is that you write code for once, and then you try to abstract it away and take it to many other applications. And so what we're seeing, for example, these various gen-wide association studies, these secure plus query techniques for financial crime, these model training instances for Michigan and Sloan Foundation, it's generally applicable to other domains, and we start to pick them up and use them in other areas and start to move in other verticals as we go. And this was, like I said, one of kind of our activities as when we were early stage in a startup. There have been so few other companies that ever tried to do homomorphic crypto and privacy technologies as a commercial company before. A major part of our early stage activities was product market fit, and we were designing a lot of early things on purpose so we could carry it to other domains. And so we're sitting on these really nice tool chests of things that we're looking forward to applying in other domains as we go.
Where are the repositories for this open source stuff so that people can go contribute and take a look and think about ways to use it and what they're doing?
Great. No, good question. So the main open source repository for the Palisade library is, and thanks for letting me give a plug about my own little prep project, palisade-crypto.org. Spell as it sounds. The other thing is, thankfully, and I have a kind of unusual name for an American, so pretty easy to find on Google. And so my old academic website has links to this website. And one thing we're also very proud of is that Palisade project has become affiliated with NumFocus, which is one of the major open source consortia that also oversees projects such as NumPy and Pandas and CondaForge. And so if you're familiar with the NumFocus community of sponsor projects, Palisade is in this stable also. So you can find a link to us through the NumFocus website too. Thank you.
Very cool. Yeah, no, I mean, I think that folks, there's definitely some developers out there, engineers that are building cool stuff that would probably want to take a look at some of this and see how they could apply it. And I certainly think I know of a handful of projects in the blockchain space that I'm sure know of your work because it is a small community and they have other cryptography people on their team. But it's interesting to see you guys applying it, especially in the AI training and also potentially thinking about how that could be used for creating data markets. I think that's a big theme. So you've got privacy, human rights, technology, and democracy, and I think enabling people to monetize their own data in a safe and secure way is democratizing in nature, right? Like it's giving you another way to generate some kind of income off of this thing that we normally give away for free. So I just think it's a big vision for the whole space. A lot of people want to see that succeed, these kinds of data markets to succeed, but we're definitely not there, not consumer ready yet, right? There's a lot of work to do to kind of get it to that point. I'm curious to hear what you think about that. We talked about some consumer applications. You talked about the data markets. There's this obviously a huge impact from training AI on this kind of data. What else? What's like the next 5 years look like? How do you get from where we are today to kind of where you want to be? What needs to be done?
Sure thing. So there's a couple ways of answering this question, both on the technology side and on the business side. On the business side, we're marching forward. We're basically pushing for broader adoption, broader visibility, and I really think it's really more of a challenge of visibility as it is as much as anything, of enabling basically folks inside the banks, whether it's like chief risk officers, chief data officers, on the operational sides of banks to know that they have these tools and to know that these tools are trusted and trustable. And so, for us on the business side, we see market education as being huge for us, which is why we love talking about homomorphic crypto publicly and bringing people into the community and building up open source and things like that. On the technology side, like I alluded to early on, the runtime of homomorphic crypto is an aspect where we are always trying to go faster. Like anyone who does any manipulations of data, including like the deep learning, community who are always, buying, pallet full of GPUs and things like that to accelerate their technology. It's no different when running machine learning on encrypted data. Also, we're looking forward to how we can accelerate as much as possible. Whether that's on commodity devices or notional custom devices and so forth. And then the other kind of difference.
Can you speak to that a little bit more? So it's
Sure.
like how you can get more GPUs, or just how you can accelerate the ability to analyze more like larger amounts of data at scale for cheaper.
Yeah, basically that. The usual like how much compute can you do per dollar, right?
Yeah.
And how much encrypted compute can you do for dollar, and make that as inexpensive as possible as you go, right?
Well, that's
Yeah.
one of the cool things that's coming out of the blockchain space is decentralized compute platforms. You got to check out. I invest in this company, but so disclaimer there. But you got to check out Akash. The guys at Akash, they big time in open source and building out decentralized compute platform. Really cool that they've got. They just launched their mainnet and the token, and I think it's a lot cheaper than like AWS or whatever, the stuff
Cool.
that we find so off the shelf. But very cool.
Yeah, I didn't know
Well,
you had the connection. I've heard of those guys actually. That's a pretty
yeah,
wild technology. Yeah. Yeah.
yeah. Greg and I became friends when I first started working at Orchid, and just a good guy.
Cool
So
stuff.
very cool. So you were saying better, faster, cheaper, basically now servers, GPUs, and what was the thing you were going to say after that?
Yeah, and the other kind of side of it is that this is also one of the other kind of little slightly hidden secrets of these privacy technologies is the compute model is very different. And there's an analogy I like to use, right? Where most of us were born with 10 fingers and 10 toes. And so we have our kind of like first gen compute hardware is built on base 10 math. And so, you learn how to, add base 10, multiply base 10 and everything else. We go off to engineering school and we get these devices and we start to learn how to program them. Well, underneath them, there's all these transistors which are based around base 2 math. And so we learn about things like binary trees and binary search algorithms and kind of like the native kind of base 10 algorithms that we've been kind of like natively kind of intuitively built up from childhood, have to get translated over to these other devices. And we as computer scientists, we've been in the space for so long, we don't even realize it about how there's the translation of algorithms that are efficient for mental models over to RAM, transistor-based RAM devices that's just wildly different, and we don't even realize they're wildly different just because we've been breathing them for so long. Well, the other side of it is that homomorphic crypto provides its own kind of compute model where the base primitives aren't the flipping of like a transistor, but it's the addition on vectorized addition of integers and vectorized multiplication of integers. And so you start to get this very different compute model where it looks more like programming circuits, programming FPGAs, and other kinds of circuit-based compute devices. And so the nature of translating software that one might write, naively for Java or C or Python that's intended for a traditional RAM device, and then to try to port it over to a homomorphic crypto compute model, it generally doesn't work all that well. Kind of like, when people first started designing the very, very earliest computers back around World War II and early Cold War, they weren't using base 2 devices. They were using base 10 devices because, that's what they knew, and they didn't work all that well. They were just horribly slow. And so it took this kind of breakthrough of going to base 2 compute models, base 2 algorithms, base 2 data structures that really set the stage to enable all these major compute technologies that have kind of come out of that since the 1950s. And I see similar kind of technologies with homomorphic crypto, where we have to basically rethink the underlying algorithms, rethink the underlying data structures, which is really what Duality is advancing and pushing on, and kind of a lot of our core technologies is how we do data science, and kind of like where there's a kind of a big leap from people that get into the space and make it usable and real, and that's what we push on. And so the concept of that is that there's a lot of things that we know how to do very well and very efficiently. Vectorized addition, it's like a native compute almost for homomorphic crypto. And then there's things which are just very hard to put into this model, and things like free text processing. It's very, very hard. And then there's a lot of gray space where we haven't quite figured it out. And we are basically enabling, taking things that we're finding of value to our customers that might be in that gray space, and figure out how to make it practical. And things that we've been working on this is, for example, this training example that I gave, or the gen-wide association example that I gave earlier, are things that we're trying to push the envelope, bigger scale, more compute, and more capabilities and functionality as we go. So.
Very cool. Well, we're about 42 minutes into the show, and typically lasts about 45, 50 minutes. So I always ask this question at the end of the show. What have I not asked you that I should have asked, or that you want to talk about?
Oh, good question. I would actually, being an open source guy, I always like to tell people how they can get involved.
Yeah.
Right. And so, Palisade, the Palisade library that we have, it's all written in C++. It's never, we always want to improve it, always want to get it better. We're always looking for people that want to download it, test it, documentation, all the usual things like that. We've been particularly focusing on Duality at more enterprise style applications. We'd love to have more people looking at, mobile, get it ported over, running very efficiently on iPhones or Android devices and things like that, push the envelope and push it into consumer devices. So we would love to have people that want to do that, and, happy to engage with, folks that want to join the community and kind of pitch in as we go. So.
Very cool. Very cool. And what's the best way for them to contact you and reach out to you if they're interested in doing something like that?
Shoot me an email. Any number of email addresses I have, I'm pretty easy to find. Or there's contact@palisadecrypto.org. It's on the Palisade website also. It goes to myself and Yuri Polyakov and Dave Cousins, who are my co-founders of Palisade, and they've been my partners on this project for many years. And actually, I want to make sure I actually give them full credit because they've been wonderful to work with. These things are not individual projects. They're always team efforts. And Yuri and Dave, and also Jerry Ryan, who's been a long collaborator of ours, I want to make sure I mention their name whenever I can.
Awesome. Well, I think that's a good note to wrap up on. I really appreciate your time being on the call, and that was super interesting to hear. And I look forward to watching your progress and seeing what other applications get built on top of this tech that you guys are building. It's super important. Thanks so much.
Thanks for your time. I appreciate it.